The Bagger 293. The Bagger 293 bucket wheel excavator is the largest land vehicle ever built by mass, and it moves with the slow, inexorable patience of something that knows nothing can stop it. Built by the German company Takraft in 1995 for the Hambach Open Pit Coal mine in western Germany, it weighs 14,200 metric tons, heavier than the Eiffel Tower, and stretches 740 feet from end to end, longer than 2 football fields laid side by side. It requires a crew of 5 to operate, and it takes about 20 minutes just to turn around. At its heart is a rotating wheel 70 feet in diameter, studded with 18 buckets, each capable of scooping out 530 cubic feet of earth in a single bite. Over the course of a day, the Bagger 293 can excavate 240,000 cubic meters of overburden, enough to fill roughly 96 Olympic swimming pools. It moves on crawler tracks so wide they look like a city street. The machine doesn't just mine, it reshapes geography. Germany's lignite mining operations literally relocated villages and rerouted rivers to feed machines like this one. Bertha. Tunnel boring machines are extraordinary objects to think about. Sealed cylinders that eat through solid earth, assembling their own tunnel walls behind them as they go, never seeing daylight until they emerge on the other side. Bertha, named after Seattle's first female mayor, Bertha Knight Landis, was for a time the largest tunnel boring machine ever built. Constructed by Japan's Hitachi Zosen Corporation and measuring 57.5 feet in diameter, Bertha was assembled underground in Seattle in 2013 to bore the tunnel that would replace the aging Alaskan Way viaduct along the city's waterfront. Almost immediately, things went wrong. Less than 1,000 feet into a nearly 2-mile journey, Bertha struck a steel pipe left underground from a previous survey and overheated, grinding to a halt. In December 2013, crews had to dig a rescue pit 120 feet deep to reach her, repair her cutting head, and restart. The delay cost years and hundreds of millions of dollars in overruns. She finally completed the tunnel in 2017 and was disassembled underground. TBMs are typically taken apart once they finish, because there is no practical way to retrieve them intact. The cutting head alone weighed over 2,000 tons. The Caterpillar 6090FS. Caterpillar is a name synonymous with heavy equipment, but the 6090FS represents the outer edge of what hydraulic excavators can do. Originally developed by O&K and then acquired by Terex before Caterpillar absorbed it into their lineup, the 6090FS is one of the largest hydraulic mining shovels on Earth, weighing over 1,000 metric tons when fully configured. Its bucket can hold between 52 and 70 cubic meters of material in a single pass, enough to fill a standard dump truck with one scoop. Designed to work alongside ultra-class haul trucks in large-scale open pit mining operations, its productivity is measured in millions of tons of earth moved per year. Unlike rope shovels that use cables and drums, hydraulic shovels use fluid pressure, which gives more precise control and faster cycle times. The 6090FS can complete a full dig and swing cycle in under 30 seconds. Machines like this have transformed mining economics. Fewer machines, each moving more material, with smaller crews, operating in copper mines in Chile's Atacama Desert, iron ore operations in Australia's Pilbara region, and coal mines across Wyoming's Powder River Basin, running around the clock in temperatures that range from scorching heat to Arctic cold. BelAZ 747. Most giant machines live in mines or construction sites hidden from ordinary life. BelAZ 747 is different. It is a farm tractor, built for American agricultural land so flat and vast it demands its own category of machinery. Constructed in 1977 by the Northern Manufacturing Company in Havre, Montana, for a California farming operation, BelAZ was designed from the start to be the most powerful farm tractor ever built. It weighs 100,000 pounds, stands 14 feet tall, rolls on tires 8 feet in diameter, and produces 900 horsepower from its Detroit diesel engine, later upgraded to 1,100 horsepower. Its fuel tank holds 1,000 gallons. Built to pull the widest implements across the largest fields, it was capable of tilling 24 rows at a time. After passing through several hands and spending years in storage, BelAZ was eventually purchased by Robert and Randy Williams, who restored it and still use it on their farm today. The NASA Crawler Transporter. The Apollo program needed rockets, but before the rockets could fly, someone had to figure out how to move them. NASA's answer was the Crawler Transporter, a machine so large and slow, it seems almost geological in its movement. Built in the mid-1960s by Marion Power Shovel Company, the 2 Crawler transporters at Kennedy Space Center each weigh about 2,700 metric tons unloaded and travel at a top speed of 2 miles per hour, or just 1 mile per hour when carrying a fully loaded rocket. They move on 4 double-tracked crawlers, each track link weighing a metric ton on its own. The platform on top is kept level by a hydraulic system accurate to within 1 degree, because a Saturn V rocket or space shuttle cannot be tilted even slightly during transport without risking structural damage. The 3.5-mile journey from the vehicle assembly building to the launch pad takes roughly 5 hours each way. The crawlers burn about 150 gallons of diesel fuel per mile. They have carried every American crewed rocket since Apollo, and after upgrades completed in the 2000s, they now support NASA's Space Launch System. The Prelude FLNG. The Prelude FLNG, a floating liquefied natural gas facility, is not a ship in any conventional sense. Built by Samsung Heavy Industries in South Korea for Royal Dutch Shell and completed in 2013, it is the largest floating structure ever built by human beings. 1,601 feet long, 243 feet wide, and displacing 600,000 metric tons when fully loaded with ballast, 6 times the displacement of the largest aircraft carrier. It is essentially a floating industrial city and gas processing plant, designed to operate over the Browse gas field off the northwest coast of Australia. without ever coming to shore. Natural gas is extracted from the seafloor, piped up to the Prelude, liquefied by cooling it to minus 162 degrees Celsius, stored in enormous onboard tanks, and transferred to LNG tankers that pull alongside. The facility can produce 3.6 million tons of LNG per year. It is moored by a turret system that allows the entire structure to weather vane around the mooring point in response to wind and current, always presenting the bow to the worst weather. Cyclones, which regularly sweep the region, were a primary design consideration. The BelAZ 75710. Mining operations need machines to dig the earth, but they also need machines to haul it away, and no hauler on Earth is larger than the BelAZ 75710, built by the Belarusian manufacturer BelAZ, a company that has been building massive dump trucks since the Soviet era. The 75710 entered service in 2013 and immediately claimed the record for the world's largest dump truck. Its payload capacity is 450 metric tons, roughly the weight of 150 mid-sized cars, all riding in a single bed. The truck itself weighs 360 metric tons empty, rides on tires nearly 13 feet tall, and is powered by 2 diesel engines working in tandem to generate 4,600 horsepower, more than 4 Formula One cars combined. It uses diesel-electric drive, where the engines generate electricity that powers electric motors at each wheel, the same principle used in diesel locomotives. The 75710 is so wide that it requires a specially designed road. It simply cannot fit on a normal one. Its turning radius is enormous, and its path through a mine site must be carefully planned. Despite its scale, BelAZ claims it can still achieve cycle times competitive with smaller trucks because of how much it moves per trip. One of these machines costs approximately $6 million. The Liebherr R9800. Switzerland's Liebherr Group is one of the most respected heavy equipment manufacturers on Earth, and the R9800 represents the peak of their hydraulic excavator line. Weighing 810 metric tons, it is purpose-built for ultra-class mining, specifically designed to work alongside the largest haul trucks in the industry, filling a 400-ton truck in just 4 to 5 passes. It is powered by 2 diesel engines producing a combined 3,000 kilowatts of power. The boom and arm assembly alone, the articulated structure that connects the machine's body to its bucket, weighs hundreds of tons and is engineered to absorb constant, punishing impact cycles over a service life measured in decades. Liebherr machines are known for their German-Swiss precision engineering, even at scales where precision seems almost impossible. The hydraulic systems in the R9800 must manage enormous pressures while maintaining fine control over bucket positioning. These machines often work in iron ore, coal, and copper mines, where margins are thin and downtime is catastrophically expensive, so reliability is engineered in from the start. Operators sit in a cab mounted high on the machine's upper structure, with views over the mine floor that feel more like an aircraft cockpit than a construction site. The Komatsu D575A superdozer. The bulldozer is one of the most fundamental machines of the modern world, the machine that literally builds the world by moving the earth on which everything else is constructed. And the Komatsu D575A superdozer is the largest bulldozer ever built. Developed by the Japanese manufacturer Komatsu in the 1980s and updated since, the superdozer weighs 152 metric tons and produces 1,150 horsepower from its turbocharged diesel engine. Its blade, the curved steel plate that pushes earth, is 24 feet wide and over 9 feet tall, capable of moving enormous quantities of material in a single pass. It was designed specifically for surface mining operations, where massive amounts of overburden must be pushed and graded before excavators and haul trucks can work efficiently. Unlike excavators that lift and place material, a dozer simply pushes, brute force applied horizontally, relentlessly, hour after hour. The superdozer is so heavy it must be transported in sections by multiple trucks and reassembled on site. It cannot be driven on public roads. In machines like this, Japan's tradition of manufacturing precision, the same tradition that scales from consumer electronics all the way up to mining equipment, is fully, unmistakably on display.